midterm review here. And here we go. Like we said in Unit 3, remember atoms are the simplest part of the element that still acts like that element. But what's most important about this section is the electrons. And actually, I'm getting ahead of myself. That's later in this. Right now, we're going to review what's in the nucleus, where the electrons are, the charges of all these parts, and then the importance of all these parts. So if you look at the picture here, this middle part with the purple and green, that's the nucleus. So within the nucleus, hopefully you remember we're going to have protons and neutrons in there. Protons start with a P, they're positive, and neutrons start with an N, they're neutral. So easy to remember what charges they have. And really, we don't even count the electron's mass, it's so small, so all of the mass essentially is in the nucleus, because all we're concerned with are protons and neutrons when determining mass. Protons are what determines what kind of element you have. If you look down here, it says atomic number for oxygen is 8. That means oxygen has 8 protons. In a neutral atom, it also has 8 electrons, but it can lose electrons or gain electrons or share electrons and still be oxygen. It cannot lose or gain protons because it would become a new element altogether. What we call that number of protons, that 8 in this instance, is the atomic number. Again, it tells us the number of protons and electrons, but what's most important is protons. The neutrons we said are neutral, and they vary. Different elements, the same element, but different atoms of them can have different numbers of neutrons. We'll learn again here in a minute that those are called isotopes, but if we look down here in this picture, we can see carbon 12, carbon 13, and carbon 14. Notice 6 protons, 6 protons, 6 protons. Those can't change, and since this is neutral, we also have 6 electrons in each case, but 6 neutrons in carbon 12, 7 neutrons in carbon 13, 8 in carbon 14. Since they're neutral, they don't affect the properties, they only affect the mass. So it's you can have different amounts of the same in the same element. The atomic mass, we said we're only going to be concerned with protons and neutrons, all found in the nucleus. Each of them have what's considered an AMU, an atomic mass unit. So if you have 1 proton and 1 neutron, you add that together. 1 plus 1 is 2 would be the atomic mass of that element. Really, you just add protons and neutrons and you're good. Electrons, we said, are negatively charged. They basically have no mass. They go random directions and super fast, but they are found outside the nucleus on what we call energy levels or clouds. And each level can only hold a certain number of electrons. This is super important to remember for this unit. First energy level holds 2 electrons. Second can hold 8, third can hold 8. Fourth and fifth can each hold 18, sixth 32. You won't need to go up that high, but those are the number of electrons that can fill each energy level. So press pause and start filling out your notes. So to review, protons, positive charge, found in the nucleus. Neutrons, no charge or neutral charge, also found in the nucleus. Electrons, negative charge, found in the electron cloud around the nucleus. The nucleus is that center, really dense, small part of the atom. And each element has a unique number of protons that match the electrons in a neutral element. Go ahead and fill this out. It's important you know where each of those subatomic particles are. So pause while you put this into your notes. All right, so atomic number, we said, is the number of protons, period. In this picture, 47, so silver has 47 protons and also 47 electrons. The mass number, in this case, 107.87, in this case, 12, is the number of protons plus neutrons, because we said that's all that matters. So if we look at this element here, hopefully we know this means there's 6 protons and also 6 electrons. But how many neutrons are there? Well, 12 is the number of protons plus neutrons. So if we subtract 12 minus 6, that will give us, in this case 6, the number of neutrons. So subtract the mass number minus the atomic number, and that will let you determine how many neutrons you have. Much of the same here. Press pause while you fill out the difference between atomic number and mass number. So these are isotopes, which if you recall, we said are the same element but different number of neutrons. So how do we know how many each of them have? Well, we subtract. Remember, 1 minus 1, this one has 0 neutrons. 2 minus 1, this has 1 neutron. And this one is 3 minus 1, which would be 2 neutrons there. If we look here, we have a mass number for chlorine of 35, atomic number 17, subtract, and you get 18 neutrons in this isotope. This has 37 for a mass number. Atomic number has to be the same. And 37 minus 17 would give us 20 neutrons there. So just subtract the two and you'll be able to find out neutrons. Pause while you throw this into your notes. I already said that. It's a little out of order actually, but we're going to review the energy levels because it's going to be essential when we do our Bohr model and Lewis dot. So remember, the first energy level can only hold 2 electrons. Second energy level for electrons holds 8, third 8, fourth 18, fifth 18, and sixth 32. So pause and put that in, and then we'll get into how to do the Bohr model and Lewis dot. All right, since we've done this and we are pretty good at it, I'm not going to go through step by step how to do them. If I were you, I'd actually press pause and in the first 2 boxes of your notes, see if you can draw the Bohr model for these two, if you remember how. If not, that's all right. I'll show you in a minute. And then the last 2 boxes are going to be the Lewis dot structures for these also. So if you could do all that while you press pause, that'll actually finish most of your note guide. Just fast forward to the end and you're done and you could do the review games. If you don't know how to do it, just keep watching and I'll show you here in a second. All right, so if you remember, first thing to do when we're drawing a Bohr model is draw a circle and put the number of protons in the middle. How do I know the number of protons? It's the atomic number. So for number 1, I'm going to put 10p here. And then I have to tell us where the electrons are. There's 10 of them, remember, the same number of protons. And that first energy level can only hold 2, so I'm going to draw 2 there. All right. I have to draw a new level. How many can that second level hold? 8. So I'll put 2, 2, 2, and 2. What's 10 minus those 8? It's 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. I haven't gone over the number of electrons allowed on each energy level. So that's what you're going to draw in box 1. Box 3, I'm skipping on purpose because once you do a Bohr model, the Lewis dot structure is very easy because that's what's going to go in box 3. For Lewis dot structures, all we care about are the electrons on the outer circle, the outer energy level. So for Lewis dot, if you remember, you draw the symbol of the element, which I just got from over here. And then you just draw the number of dots around it that are on the outer level only. Well, we had 8 around it, so I'm just going to put 8 dots around NE. And then you're done with the neon. So pause while you put that in your boxes. Again, your note guide has 4 boxes. Box 1 should look like this. Box 3 should look like this. And now we're going to show you how to do box 2 and 4. If you didn't go ahead and do this, you were confused, needed to see my review, if I were you, I would pause now and see if you can do box 2 and 4. See if it refreshed your memory. If not, just wait a second and watch what I do. All right. So for chlorine, the Bohr model, first step, draw a circle, write that atomic number in it, and put a P next to it for protons. Then we have to put 17 dots around it for electrons, but we can only put 2 on that first level. So I draw another level. We could put 8 there, so I'm going to put 8 there. And I've put 10 dots so far, so I need 7 more to get to that 17 total. So I have to make a third level. It could hold 8. It doesn't have to. I'm just changing the color to make it easier to see. It can hold less than 8 too, and ours only needs 7. So that's what we're going to put. And that's our Bohr model. It's got 17 electrons, fits our 288 pattern, so we're good. So that's what you're going to draw in box 2. Box 4, remember, we just write the symbol for the Lewis dot structure and the number of dots on the outer level, which are 7 this time. 1, 2, 3, 4, 5, 6, 7. Make sure you draw that in your notes. Press pause while you do it before I change the slide. Remember, you should have already filled those out, and add the bottom part of your notes, and then you are done. So pause it here, leave it here until you finish, and then work on your review practice questions.